Okay, in this video we're going to talk about Boyle's law, which we've already found out to be P1 times V1, which equals P2 times V2. And so we've already discussed how we came up with this equation, but I want to go over it again. Boyle's law, P1 V1 equals P2 V2. That means a pressure 1, let me get my pen out here, that we have some pressure 1, let's say is at 2, the volume is going to be at 6. Well, if we go and measure the pressure 2, we can say is 3, the volume will be 4. And we can set these in the equation. So we take 2 for the pressure times 6 on the volume. That should equal, put a multiply sign in there, that should equal pressure 2, which we see here is 3, times the volume 2, so at 3 we're at 4 volume. And this is right, 2 times 6 is 12, and that is equal to 3 times 4, which is also 12. So Boyle's law would be graphed out like this, as just saying P1 times V1 would equal sum pressure 2 times volume 2. And remember, for Boyle's law, temperature is constant. So down here in our little chart, or our little picture of a cylinder being compressed and heated, it's heated at 300 degrees Celsius here, and again at 300, or this could be Kelvin, it doesn't exactly say on here, but the temperature is 300 and it stays 300. But we changed pressure. Originally the pressure is 1, we changed the pressure to 1.33 because we are decreasing the volume. Here we have a volume of around 4 right there, and we're going to decrease it to about 3. And you notice that the pressure is also changing, but what is not changing is the temperature. It stays the same. So, and also, so we need to take into account the temperature is not changing, and also the number of moles of gas. So that is how many little particles we have in here. That's not changing. We keep the same amount of particles. So we'll discuss later on what that means, as in, or what can happen if we don't keep those constant, but for right now we're saying those are constant, and under those conditions we have Boyle's law. A pressure 1 times that volume 1 will equal pressure 2 times that volume 2. So let's put Boyle's law in action here with a little word problem. Okay, so our challenge. The pressure on a 425 milliliter sample of gas is decreased from 855 millimeters of mercury, that's one way to measure the pressure, to 759 millimeters of mercury. What will the new volume be at constant temperature, and we're not changing how many moles we have of gas? So let's highlight some terms here. The pressure is 855 millimeters of mercury to 755 millimeters of mercury, and we'll do volume in green. The volume is 425 milliliters. So this is a V1. This will be our V2 because it's going from V1 to V2, and at this pressure we have this volume. So this is V1. Oh, I already made a mistake. This is pressure, sorry. So at this pressure 1, we have that volume 1, and this is our pressure 2. So let's write these out in an equation. And the equation we're going to use is Boyle's law, so we're going to use P1 V1 equals P2 times V2. Our unknown is the volume, the new volume, which is V2. So we're solving for V2. Now before we plug in, we can rearrange this equation to get V2 by itself. So all we got to do is take P2, divide it on both sides, and so we have P1 times V1 divided by P2 will give us the new volume. Okay, so now all we have to do is plug and chug. So let's plug in our numbers here. Pressure 1 was right here, 855 millimeters of mercury. We're going to times that by V1, which was 425 milliliters, and we're going to divide that by our pressure too, which is going to be 759 millimeters of mercury. All of this will equal V2. Now, before we even finish this, our pressure is decreasing. We are, because I want to think of what should happen to our volume. Should it decrease or increase? Well, my pressure is decreasing. It's going from 855 to 759. We go back up to the top here and look at our graph. As pressure decreases, so going from 3 to 2, our volume should increase. So they're inversely related. As pressure decreases, volume will increase. Or we could also say as volume decreases, pressure will increase. So we go down here. Since our pressure is decreasing, 855 to 759, our volume should increase. So hopefully we get something bigger than 425. So let's bring up the calculator here. So I'm going to go 855 times 425, and then I'm going to divide that by 759. And I get 478.8. I'll round it to one decimal place. So 478.8. Right? Yep. So 5's after 7, so I'll round up to 0.8. Now the units, what units do I have? Oh, well, I'm going to go back to my equation here. Millimeters mercury cancels out with millimeters mercury, and my unit should be milliliters. Boom. V2 equals that. Alright, so that's Boyle's law in action, and just remember, our temperature is constant, and we also have to say the number of moles of gas is constant. And we said at a constant temperature, and we're saying this is a closed container, so our moles of gas is not changing. So yeah, there's Boyle's law in action.